Welcome back. In previous lessons we've learned quite a lot about a sort algorithm called the bubble sort. In the next 2 or 3 lessons we're going to learn about a new sort algorithm called the insertion sort. In this lesson we won't be writing the program code yet. Instead you'll learn how to describe what happens in the insertion sort. We'll demonstrate it by sorting a list on screen. You'll see how to recognize the insertion sort if you see the code, and you'll evaluate it, particularly in comparison to the bubble sort. So how does the insertion sort work? Let's just quickly go through it in simple terms. A marker or counter passes down the list, so that's a simple list traversal. All the items behind the marker will be in sorted order, and the way this is achieved is that the value 1 in front of the marker is compared to the marker, and if it's smaller it's passed backwards up the list until it reaches its correct position and it is inserted into the sorted half of the list, and the marker moves on. Because everything behind the marker is sorted, we only need to traverse the list once. So we use a for loop. We could use the counter value I as the marker, and we'll traverse in the range up to the length of my list -1. So that's the same as we see for the bubble sort, but with the insertion sort we only need to traverse through the list once. Inside that for loop we have a backwards loop, and that will pass values backwards up the list until they reach the correct position, and then we'll leave them. So there's a forwards loop that goes through the list once, but inside it is a backwards loop that passes values backwards to their correct position. So that's how we will recognize the insertion sort. If we were shown some code, for instance, and asked what sort is this, if you see 2 for loops and the first one goes forwards and the second one goes backwards, that's a big clue that you're looking at the insertion sort. Is this a fast sort? Well, it's almost always faster than the bubble sort, but it's still not a very fast sort. So it's better than the bubble sort, but it isn't what we would call a really fast sort. If you're my students, they're not as little as that, by the way, but if you're one of my students, we're going to act out the insertion sort in class. But if you're not my student, or you are my student and you want to see it again, let's look on the screen at how the insertion sort would sort a list. So here we've got a list of 10 elements and the marker is pointing at the first element. We compare the value at the marker with the value that follows it. So we compare A with G. Are they the right way round? Well, in this case they are, so nothing happens and the marker moves on. Now the marker is at the G. We compare G to the value that follows, which is C. Are they the right way round? No, they're not. So the backwards loop comes into action and C is passed backwards until it reaches its correct position. So C has been passed back to position 1. Why is it stopped at position 1? That's because C is bigger than A, so the swapping stops when we reach a value that is smaller than the value that we're passing backwards. And that way each value reaches its correct position. Okay, and the marker's moved on. The marker is still at the value called G, and we compare it to the value that follows, which is B. So once again the backwards loop comes into operation and B will be passed backwards up the list until it reaches a value that is smaller than it. So after that's happened, it will look like this. So B has been passed back until it reaches a value that is smaller than B, and at that point the backwards loop stops. So A, B, C, G. So the mark has moved on to position 3. We're going to compare G with H. So what happens next? Complete the rest of this demonstration on paper using the same principles that I've just shown you, passing values back if they're smaller, leaving them where they are if they're larger, and the marker moves on until it reaches the final element in the list. So how is the insertion sort different from the bubble sort? If you remember, in the bubble sort, we always swap our values back by 1. We never swap back further than that. But in the insertion sort, once we start passing a value back, we'll pass it all the way back to where it belongs in the sorted half of the list. That means the insertion sort can be completed in one traversal of the list. So what's the big O value? As we know, traversing a list takes n operations, but in the worst case, every single item in the list would be in the wrong place, and every single item would have to be passed all the way back to the start of the list, which is itself n operations. That means in the worst case scenario, we'd have n inside n, that is n squared, and that is exactly the same big O value as the bubble sort. So have we gained anything at all? So is it true that the insertion sort is no better than the bubble sort? Well, as we've seen, if we look at the mathematical theory, it can be just as bad. But in practice, when we use it in our real life programs, it's almost always faster. The worst case scenario only occurs if the whole list is in completely reverse order. And if this is not the case, it's almost always faster to use the insertion sort instead of the bubble sort. And I would recommend that in your everyday programming practice. In fact, if we've got a list that's already quite well sorted with only a few values in the wrong place, then the marker will move quickly up through the list and the small number of out of place values will be spotted by the algorithm, passed back and inserted into the correct location. And in this case, the insertion sort will actually work very quickly indeed. So you should be able to describe and show how the insertion sort works. You should be able to recognize it because we'll see a forward loop with a backwards loop inside it, and we should be able to evaluate it. And what we would say if we were evaluating it is that it is in principle can be as slow as the bubble sort, but in real life it's generally quite a lot faster. And when we have a list with only a few items out of place, the insertion sort is a very quick way to tidy that list up and return it to sorted order. So I'll leave you with an activity. Here's a short list, 4 items. Show step by step how the insertion sort would sort this list. Show the marker, show it moving up through the list and how the items will be passed back into their correct position. In the next lesson, we'll create a program to do the insertion sort. So see you then. Bye for now.